Hey guys, welcome back to my YouTube channel. Today we'll be attempting LeetCode problem 7, reverse integer. This one's a medium, so my first medium, but this one's not going to be that hard because I kind of know the formula already. Given a signed 32-bit integer, x return x if it's reversed. If reversing x causes the value to go outside the signed 32-bit integer range, and return 0. What we're going to do is store x on some new variable x, or s, but it's absolute value. And then we could say reverse to 0 right now. So this is going to be what we're going to be returning eventually. So while s is greater than 0, digit is going to equal s mod 10. So what we're going to be doing is, let's say we're going to pass x equals negative 1,234. So then s is going to be just 1,234. So we're going to get s mod 10, which is 4, right? The remainder of that. Cool. Next what we're going to do is, we're going to have reverse be reverse times 10 plus our digit. So right now reverse is 0. 0 times 10 is 0. Plus our digit, which is 4. Reverse just becomes 4. And then lastly, x is going to be just x divided by 10, but integer division. So x equals x divided by 10. 1,234 divided by 10 equals... Where? Oh dear. Oh, 내가 사줄게. 괜찮지. 맛있어. 치즈 가잖아. 응. Sorry about that. Anyways, today, I went hiking and it was pretty fun. But tomorrow, I read about my mom once, so yeah. Anyways, 1,234 divided by 10 is normally 123.4, right? However, integer division makes it so that it's going to return an integer. So 1,234 divided by 10 is going to equal just 123. Cool. So now, oh shoot, I forgot s is, it's not x, it's s. So now that s is 123, we're going to pass that through. 123 mod 10 is 3. And then keep in mind right now, reverse is just 4. So 4 times 10 is 40, plus our digit, which is 3, is 43. See where it's going? It's going to be reversing it. And then now s is going to be s divided by 10. S is 123. 123 divided by 10 is 12.3, but we know that s is 12. Cool. Now s is equal to 12. So 12 mod 10 is 2, right? And then right now reverse is 43. So 43 times 10 is 430, plus 2 is 432. And then s currently is 12, so 12 divided by 10 is 1.2, which is 1. Now, finally, s equals 1. So s1 mod 10 is just 1. And then right now, reverse is 432, so 432 times 10 is 4,320 plus 1 is 4,321, which is the reverse of this. Not this yet, we're going to have to address that later. And then right now s is 1, so s divided by 10 is 0.1, but that's just 0. Cool, now s is not greater than 0, and we can exit the loop. So, however, we have these boundary conditions. If x is either less than negative 2 to the power of 31, or, oh shoot, reverse. Sorry, the reverse string is either less than negative 2 to the power of 31, or 2 to the power of 31 minus 1, we can just return 0. Cool, and then if our x is less than 0, not s, x, if our x is less than 0, so if x is negative 1,234, then we gotta return reverse times negative 1, and if not, then we could just return reverse. It should work. Oh, what happened there? If reverse is less than... Oh, I forgot the... Sorry, it's kind of late right now. Okay, yeah, it should work. This one's really just a formula, it's just, oh nice. I'm not really going for a fast time here, but, yeah. I'm probably gonna redo the palindrome number now, so this will be a longer video, but see you there. I know I already did this one, and I said it was super easy. However, today we're going to be trying it without converting it to an integer. So, how are we going to do this? Okay, so first of all, if it's negative, just return false. Okay. Now what we have to do is, we're going to take the original, so let's store the original in value in a variable called original, and then we're going to do this. While x is 0, we're going to have to do it. Do this. We're going to put reverse. We have to reverse the string, so, and then we're going to check if the original does a reverse. Okay, so while x is 0, what we're going to have to do is digit equals x mod 10. Okay, so I'm kind of like confused on how to do this. So let's see if we have 1, 2, 3. Mod 10 would be 3. So mod 10 would be 3. And then what do we have to do? Reverse equals reverse times 10 plus our digit. And then we would have to change our x by dividing it by 10. X equals x divided by 10. Okay, let's see how this one does. Okay, so we have 3, and so reverse is 0, so reverse times 10 is 0, plus digit is 3, and then x integer divide by 10 equals 12. So 123, 10 equals 12. So let's pass x to this, so 12 mod 10 equals 2. Right now reverse is 3, so 3 times 10 is 30, and then 30 plus 2 is 32. And then right now our x is 12. So 12 divided by 10 equals 1. And then 1 mod 10 equals 1. 32 times 10 is 320, plus 1 is 321. And then 1 divided by 10 equals 0. So yeah, and then that's when we would, if reverse equals original, return true. Okay, this one should work. Yeah, see if it passes the test cases. Oh shoot. Output is null, expected false. Wait, what? If reverse equals... Okay, for 10, it'll be 10 mod 10 is 0. Wait, why wouldn't that work? Okay, 10 mod 10 is 0. Oh shoot. I guess this digit equals... digit equals 0. It just return false. That works? I don't know, this one's kinda hard if you do it like this. How would this keep getting... I literally passed 1, 2, 3 into it. Output. No, it wouldn't work because... Wait, okay. Where is it outputting now? This one's like the first one I'm kind of having trouble with. Okay, wait. Let's see what's the reaction from the device. Let's go to 0. Well, x is 0. Take it equal x mod 10. 30 versus 8. Let's do this with a 3. X equals x mod 10. I'll divide by 10 times. Why would that work though? This is really bad. Not return. Oh, I forgot. This is a return false. That's smart. I'm not that smart. Sorry, it's kind of late. Okay, cool. This one wasn't too bad, I guess. I'm gonna try that with the strings earlier. That one's pretty easy, but why this one's a little harder is because of this algorithm where you're reversing the integer.